Hello, welcome to Hello, welcome to another ramble. We are busy with the department's paper 1 from November 2022. And we are looking at question 2.1, which is a question on geometric patterns. So, let's see. The first term of a geometric series is 14 and the sixth term is 448. Calculate the value of the constant ratio R. Okay, so we are told that term 1, which is also just called A, is 14. Okay, and the sixth, actually now also, just need to be careful. Okay, so technically, this is so confusing. Okay, right. So geometric series is just the sum of a bunch of terms. Okay, right. So we are being told, okay, so it would be term 1 plus term 2 plus term 3, blah, 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 blah. Okay, right. And we're told that this first term, okay, is 14, and the sixth term, so T6, which is going to feature somewhere here in the ... that term is 448. Okay, right. I hope I'm interpreting this right. It will be very awkward if I'm not. Okay, so calculate the value of the constant ratio R. Right, so term 6, we would work out as, we know that for geometric patterns, the nth term is A times R to the n minus 1. In this case, we know that A is 14. We don't know what R is, and our n is 6. So 14 times R to the 5 is equal to 448. Okay, so 14R to the 5 is equal to 448. Divide both sides by 14. And then we have R to the 5 is equal to 32. And if we take the fifth root on both sides, we get R is equal to 2. 32 is the same as 2 to the 5. So our R is equal to 2. Okay, before we go too far, let's just see if that is in fact correct. Yes, R is equal to 2. And you also get full marks if you just said R is equal to 2. Interesting. Righties. So now, determine the number of consecutive terms that must be added to the first 6 terms of the series in order to obtain a sum of 114,674. Okay, so there's a couple of ways that we can skin this cat. So essentially what's going on is we've got term 1 plus term 2 plus term 3 plus term 4 plus term 5 plus term 6 plus term 7 and term 8 and wara until this guy, and I need to shrink stuff. Okay, so we want this to equal 114,674. We need to figure out, okay, how many terms are we adding on? So yeah, how many terms are in here? So my instinct is to, figure out what do the first 6 terms add up to, and then I am going to, no, that's not what I want to do. Yes, okay, that is what I want to do. So I'm going to figure out, well, okay, what is S6, right? S6 is the sum of the first 6 terms. Okay, then I want to figure out, well, how many terms in total would I need, right, in order for Sn to equal that. Okay, and then once I know that, then I know, okay, I already have these 6 adding up to whatever, so the rest of these are giving me the top up. and I can then figure out how many terms are in this little block that then make S6 top up and go up until 114,674. Okay, so let's start by figuring out S6. So S6. Okay, and we know with geometric series, Sn is equal to A times r to the n minus 1 divided by r minus 1. So here our A is 14, our r we worked out to be 2, n is 6 minus 1 divided by 2 minus 1. Okay, so calculator, 14 times 2 to the 6, which is 64, minus 1 gives us 882, and at the bottom we just have 1, so this is 882 in total, and this can also definitely fit on this line. Okay, right, so now we know that the first 6 terms add up to 882. We want to get all the way to 114,674. So I want to figure out how many terms do I need to add together so that they sum up to this, right? So we know again our A is 14, our R is 2, our N we don't know, and that's what we're going to try to solve for. So we have 114,674 is equal to 14 times 2 to the n minus 14. I just multiply that 14 in. This works out to just be 1, dividing by 1, potato, potato. Okay, then we want to get the n by itself, so I'm going to add 14 on both sides to get rid of this guy. And so we have 114,688 is equal to 14 times 2 to the n. Then next up we need to divide by 14. And what does that give us? 114,688 divided by 14 is 8,192. Okay, and then to figure out 2 to the power of what gives me 8,192, we can just use shift fact to rewrite this. So we then know that this is the same as 2 to the 13. Alternatively, we could rewrite this using logs, right? So we could say this is the same as saying log base 2 of 8192 is equal to n. Oops. If you then punch this into your calculator, you have, so log base 2 down here, over here, 8192, and we get our answer of 13. So those are both perfectly okay ways to go about it. Shrink that. Okay, anyway, so both ways we arrive at n being equal to 13. So what do we now know? We now know that this is 13, right? So 13 terms add up to this number, right? And the question says, well, how many consecutive terms must be added to the first 6 terms to get this total, right? So if we know that the first 13 terms add up to it, the number of terms that were added on is 7, right? Because we already have the 6 over here, and then with an extra 7, we then get to this thingy-wingy. So yeah, you would just write your answer somewhere. Answer is add 7 more terms. Okay, the things we do for space. And do we agree? We do indeed. Okay, right. Let us look at the last bit of the question. If the first term of another series is 448 and the 6th term is 14, calculate the sum to infinity of the new series. So I mean, we've just come from a series where or a sequence rather. Term 1, term 2, term 3, term 4, term 5, term 6 was 4, 4, 8. And we figured out that each time to get from one term to the next, we were timesing by 2, right? So if we now have kind of the reverse happening, right, where the first term of another series is 4, 4, 8, well, I'm writing them down as sequences, and the sixth term is 14, then what's happening is we are now dividing by 2, right? We're going backwards, or timesing by a half. Right, so in this new sequence, our R is now a half. So it makes sense that there is a sum to infinity because R is a proper fraction. It's a fraction between -1 and 1. So, right, we have R is a half, A is 4, 4, 8. So the sum to infinity will be A divided by 1 minus R. So that would be 4, 4, 8 divided by a half, which is 4, 4, 8 times 2. Which is 896. Okay, and are we in agreement with the memo? Yes, we are. Awesome. Yeah, so in terms of figuring out what R is for this new sequence, you don't have to reason about it this way. Of course, you could have gone the same route that we did before, right, where we're told that T1, which is the same as A, is 4, 4, 8, and T6, which is the same as A times R to the 5, is 14. And we know that A is 4, 4, 8, right? So that is now equal to 14. So R to the 5 would be equal to 14 over 4, 4, 8, which simplifies to 1 over 32, right? Which is again the same as 1 over 2 to the 5. Or you could say, well, in order to figure out what R is, I'm just going to then take the fifth root on this side and the fifth root on this side. And so we can work that out on a calculator. So that would be where's the nth root? Here. So that would be the fifth root of 1 over 32, which is a half. Right, so that would be another way that you would work out what R is if you didn't reason about it in this specific way. Cool. Thank you for tuning in. As usual, hope it was useful, and yeah, hope you come back for another video another time.